Hello students, today we will be going over H2.5, interpreting solutions to systems of equations solved with matrices. This is page H36 in your blue packet. Our objective, I can solve a system of equations using matrices. A system of linear equations can be represented using an augmented matrix. Okay, so augmented, A-U-G-M-E-N-T-E-D matrix, which is a matrix that stores the values of the linear system. An augmented matrix can be manipulated to obtain the solution of a system of equations. So write systems of equations. So I'm going to write that out. Systems of equations. And I just took it off so it's easier for me to write. Okay. Hopefully you can see that okay. Maybe pause the video for a minute. So again, systems of equations. Okay. All right. Next, we're going to go on to part 2 and let you know what an augmented matrix is, and I'll show an example of that. Okay. So we have our linear system, ax plus by equals c, and dx plus ey equals f right here. So our augmented matrix is just using the coefficients of each of these. So our coefficients of x are a and d, coefficients of y are b and e, and then our solutions cf go there at the end. Okay? And then our reduced augmented matrix will have 1, 0, 0, 1, and x and y. And when that's the case, if you have a reduced augmented matrix, your solution is right here at the end, x and y. Okay? So if I have this and I need to write my augmented matrix, we put our coefficients of x, 1 and 2, our coefficients of y, 3, -1, and then we put our solutions here, 5 and 3. And we put them in brackets like that. So next, we go ahead and look at our reduced augmented matrix, making sure this is 1, 0, and this is 0, 1. So if we have 1, 0, and 0, 1, that is called the identity matrix, and we go over that a little bit more next time. So if you have 1, 0, and a 2, we know that x equals 2. So I'm going to put that over here. Now, we're going to put our y value. Now, our y value, 0, 1, 1. This means you have to have a 1 there for that to be our y value. So if 1 is there, whatever number's here is going to be our y value. This time it happens to be 1. So 2, 1 will be our solution for that particular system of equations. And if you wanted to check that, you could say 2 plus 3 times 1 is 3. Does that equal 5? Yep. 2 times 2 is 4. Minus 1, does that equal 3? Yep, it checks. So you have the right answer there. Next, we're going to talk about different types of solutions associated with these reduced augmented matrices. Okay, so if your solution is a 2 by 3, you should have 1, 0, and 0, 1 as a reduced augmented matrix. Then whatever m and m are right here, those will be your solutions. If you end up with a matrix where the reduced augmented matrix is all zeros right here, you know your solution is infinitely many solutions. Okay? Now, if you end up with 2 zeros and a number here, remember that's like saying 0 equals some other number. Doesn't matter what 1 and R right there is, but if you have 0, 0, and an N there, then it's going to be no solution, and I forgot to write that there. So we can just put empty set right here. Okay? All right. So, number 1, write the augmented matrix for the system. Give the solution for the system as a coordinate. All right. So, we have this as an augmented matrix. We're going to write down -1, -12, -18. Next one, 3, 4, -10. Okay. So that's number 1 on page H36. Now it tells you what your reduced augmented matrix is right here. Okay. So if we have that, 1, 0, 0, 1, that means yes, we have unique solutions. This is x is -6, y is 2. So for our solution over here, we're going to put -6, comma 2. Okay. I don't know where I need to go to block that off for there, but there you go. Okay, hopefully you have it written down. We're going to do our augmented matrix for, I believe it's number 2. We're going to write -14 right here, -7, -8, -4, 6, and 4. Okay, now it's actually doing most of the work for you. Right here, we have 0, 0, and a 1, and a 1, and a weird number, and 0. So what do we do with that? Do you see where I'm talking about right there? As the reduced augmented matrix for number 2. Now, if I have 2 zeros at the bottom, it will not be a unique solution. So I have to decide if it's infinitely many or if it's an empty set. So I look, do I see 3 zeros anywhere? And the answer is no. I see 1, a weird decimal, and 0, and 0, 0, 1. So that looks like it's going to be this one right here. So then I put, as a solution, I'm going to put empty set. Okay? All right, students, you can do the rest on the next page. You rock!